Hi, today we're going to be talking about the metric system. The metric system, you've probably been introduced in previous classes in science and other classes, but we're going to go into it a lot more extensive. Within physics, we use the metric system almost all the time, and we need to get familiar with the system. So we're going to talk about the metric systems, their prefixes, their base units, and all of how to convert within the metric system. There is two systems of measurements. There is first the metric system, which is what science uses, and then there is called the imperial standard units. Was created by the British, brought to the Americas by England when they colonized us. Then the United States decided to adopt that as their base unit system. So this is going to be your feet, your miles, inches, ounces, pounds, all of that. That is the imperial standard unit. Now, the metric system was created by the French. So the system of measurements, we call this SI units. It actually stands for Système International des Units. It is, or SI for short. That's the metric system. Same thing. SI, metric, same thing. It was created by the French in 1875. Over the years, it has been changed and its names have been changed over times, but eventually in 1960s, the actual international system of units came to exist as a whole body that is actually determines what things are measured in. These are going to be things like liters, meters, grams. Now, it also defined what is the prefixes, kilo, hecto, deci, deca, deci, centi, milli. So within this, the metric system makes it a lot easier. They're all based on powers of 10. So to move from one prefix to the next, all you have to do is multiply or divide by 10. Or in other words, move the decimal point. This makes life a lot easier. For example, 5 kilometers is equal to 5,000 meters, or 5 million millimeters. You cannot say that is as easy as it is for the standard, where 5 miles does not equal a nice easy mathematical find out for how many feet it is or how many inches it is. It would be very complex and requiring some level of, using a calculator. So here are all the countries that are currently in green using the metric system. So if you notice, Antarctica is not a country, so that doesn't count. So you have the United States, this country in Africa called Liberia, which was colonized and set up by the United States in the 1860s. And then you have this country, Myanmar, or Burma, however you want to call it. These three countries are the only ones still using the American standard units. Everybody else in the entire world uses metric. Now, this is the only country that uses Fahrenheit, and that is Puerto Rico. So, that's the only country in the entire world that uses Fahrenheit. Every other country in the entire world uses the Celsius scale. So, let's talk about the base units. These are the base units. These are the units that measure a quantity. So, in here, length is measured in the meters and is symbolized by the letter M. So don't get that confused because the letter M also stands for mass. So in equations, we are going to use the letter M for mass, but if it follows by a number like 12M, that means 12 meters. So you have to differentiate between the quantity and the symbol for that quantity, and then the unit and the symbol for that unit in the equations. So meter is M, is length. Kilogram is the base unit, is kg, and that's mass. This is the only one that has a prefix, is a kilogram. If you have issues with that, take it up with the French. The second, symbolized by the S, is time. Amps, or amperes, but shortened to amps, letter symbolized by the letter A, or AMP, you can see that commonly, is electrical current. Kelvin, and degrees Celsius is also common. Kelvin is technically the correct one, but you can use Celsius in most equations. So Kelvin, degrees Celsius, and that is your temperature. Candela, which is luminosity, it's how bright something is. And then lastly, in chemistry, you learned about mole, which is an amount of something. Now, other units, we can actually derive or create them from other units. So for instance, volume, if you take a meter times a meter times a meter, you get a meter cubed. So a cube, that is literally 1 meter by 1 meter by 1 meter high, that is going to be a volume. Now a liter then can fit inside that. Actually several liters fit in that. And so a liter is a unit that we can derive from the meter. A newton is just a kilogram per a kilogram times a meter divided by time squared. Hertz is a different unit. These are all derived from different things. Joules, watts, pascals, which is pressure, becquerels, which is radioactivity. All of these units come from the base units. Now, the prefixes. You will need to know some, but not all, that is listed here. And so this, you will need to know the symbol, the prefix, and the number. Either one works. So this numerical expression or the shortened version, either one works. So you will need to know from kilo, memorize from kilo down to nano. So you do not need to know tera, giga, mega. But I include that because it's really convenient because we deal with terabytes. Gigabytes, megabytes, kilobytes. That's a common thing that you see nowadays. So each one, your base unit here is 1. A deca, decade, that's where the Latin term for deca came from, is decade, and that is 10. Hecto is 100. So if you have 100 acres, that's a hectaacre. Kilo is 1,000. A kilogram is 1,000 grams. And a kilogram, by the way, is about the weight of a Progressive soup can. It's not quite a Campbell soup can, it's a little bit heavier, but about a nice hearty stew that you can find at the grocery store. That's about a kilogram. Mega then is a million, giga, billion, tera, trillion. Now we can go smaller from it, and we can go deci, kind of the feminine version of deca. Deci is 1/10. Centi, a century, a Roman centurion, which has 100 soldiers. A centimeter has 100 centimeters in a meter. So centi stands for 100, or 100th of a meter. Milli does not stand for million. That is a common misconception. Million is Germanic, it's English. We work in Latin. Milli comes from the word thousand, like millennium. So this is 1/1000th. So if you take a meter stick and cut it up into 1,000 little bits, you get a milli, or 1,000th. Micro then is going to be a millionth. This is the millionth. Now this symbol is micro. It is a two-legged U. If you take a U and put 2 legs on it, that's what the symbol is for. It comes from the Greek letter for M. So it's the symbol mu, mu, but it's the Greek letter. It's a two-legged U. And it represents the times 10 to the negative 6th, or 1/1,000,000th. And then nano is going to be 1/1000,000th. And this is like nanoscale, or you hear about nanorobots. This is the size of this would be the size of atoms, is on the nanoscale. And that is nano is -9. That's how I remember that. Nano -9. So one other thing is from kilo to milli, everything is just one step. So it goes one step from milli, so it's thousandth, hundredth, tenth, 1, which doesn't have a prefix, then 10, 100, 1,000. After kilo, and above, kilo, and below, milli, they are all in orders of 1,000. So they increase by 3 sets of zeros. So it goes from 1,000 to million, billion, trillion. Thousandth, billion, thousandth, millionth, billionth. So we can combine these combinations of teras, gigas, megas, and all that, and we can create our units. So we can then combine whatever unit, so we can say milli, adding in with a gram, and then we get the combination milligram. We can take kilo, liter, and we get kiloliters, which is about a bathtub's worth. If you take centimeter, we get a centimeter. So here's how we can remember this. This map doesn't show you all the prefixes. Again, you do need to know the ones below it. So you need to know micro and nano below milli, but this works. This helps us, and what we can use is we can go kilo, hecto, deca, base units, deci, centi, milli. So what you're going to do is you're going to find your starting position. Where is it at? An average adult male weighs about 75 kilograms. How many grams is that? Well, you're starting at the kilogram. Then you have to find where destination. Well, I want to go to base, just grams. So you count how many steps. 1, 2, 3. 3 steps, which direction? To the right, and that is the number of decimal points you move to that location. So let's do some practice problems. So how many milligrams are in 3.6 kilograms? Converting 15 liters to centiliters. How many hectometers are in 12.67 millimeters? Converting 128,650 milliliters to decaliters. And lastly, Jason runs at 1.61 kilometers. How many meters did he run? So let's start with that first one. How many milligrams are in 3.6 kilograms? Well, first we have to know where we're starting, and we're starting in the kilograms. So we have 3.6 kilograms, so now we need to go to find our end, which is our end point, milli. So then we need to count how many hops we did, and there's 6 hops. 1, 2, 3, 4, 5, 6. So we're going to move our decimal point to the same direction that many hops. So 1, 2, 3, 4, 5, and 6. So that's going to give us our final answer of 3.3,600,000 milligrams. So let's now do it again for 15 liters to centiliters. So we're starting at liters and we're going to centiliters. Again, we're going to the right and we're going to hop 2 times. So we're going to move our decimal over 2 hops, and that gives us 1,500 centiliters. How many hectometers are in 12.67 millimeters? So then again, we're starting now on the right hand side of this map. We're starting in the millimeters and we're going to go to the left. So our final destination, so direction is left, and we're going to hop 5 steps. 1, 2, 3, 4, 5. So again, we move our decimal point to the left this time, not to the right, but on the left, and we make sure we account for our zeros. And so that's going to give us 0.0001267 hectometers. So then the 128,650 milliliters to decaliters. We're going to start with our, again, to the right. We're ending on the left. Again, we're stepping this time 4 steps to the left. So we're going to move our decimal point to the left 4 spots. And that's going to give us 12.865, or you can round to 12.9 decaliters. And then Jason runs 1.61 kilometers. How many meters? Well, there is 1,000 meters in a kilometers, so you could just simply multiply it by 1,000, or we can move the decimal point three positions to the right, getting us 1,610 meters. So, to help you out, there is some acronyms that can help you remember the metric system prefixes. So there is, I've seen K hit dog, ARF, dog can't move. But on a less, dog beating, I like King Henry drink dark chocolate milk. Now, what I want you guys to do is try to create one yourself, but also adding in the micro and the nano following this, millis, so that you can figure that out. And if you so desire, you can go to even all the way up to tera, adding in tera, giga, mega, and do it all the way down to nano all the way. Again, you're only required to know kilo through nano. If you have any further questions, please ask your teacher.